Hi there. This tutorial will be covering VLANs. So what are they? VLAN, or a virtual LAN, is a broadcast domain that is partitioned and separated at the layer 2, or the data link layer. They work by applying a tag to the network frame and passing them within inter-network systems. Extremely handy for network segregation between logical groups while residing on the same physical network. By providing a software-based configuration, they can reduce costs, provide additional network security, traffic management, and simplify network deployment. In this demo, we'll be creating two VLANs with DHCP servers and a scope on each segment. Consider the two VLANs showed in this diagram: VoIP and a client VLAN. We'll be covering the implementation of VLANs on a Mikrotik 450G router. We will be creating one trunk port, which will provide port availability for both our ISP WAN connection, which will be talked about in a later demo, and other port scalability, for the other ports that are available. If we wanted to assign them for some other purpose, we could do that. By creating the trunk port, we'll allow our switch to handle specific access ports for our VLANs. But just for this tutorial, we'll be using Mikrotik's Winbox command line, and the switching and access ports on the switch will be covered in a different tutorial. So let's go ahead and get started on our implementation. You can see here the Mikrotik Winbox interface. I have the command line up. In this demo, I've already gone ahead and removed the default configuration from the router board 450G. And just a note, whenever you remove the initial configuration from the router board, you're going to need to log back into Winbox. Winbox is handy. It'll allow you to connect via a MAC address for the initial configuration. So let's go ahead and jump right into the bridge interface on the command line. The bridge will allow us to interconnect multiple VLAN segments together on our network. The bridge configuration is pretty straightforward, and it will be integral in future steps to ensure proper communication. So let's just jump on in. So now that we have the bridge created, we'll go ahead and create the individual VLAN interfaces. So we'll be creating two separate VLAN instances in this case, one for the client and one for VoIP. We'll tie each of the VLANs to our bridge that we created as well. So we'll jump into that. So there's each one of my VLANs that I've created. One for my client, one for my VoIP. Now that I've created that, I'm going to go ahead and create the IP pool that will be used for DHCP assignment on each VLAN segment. I'll be creating 3 pools, one for each VLAN and the other for my default pool or my trunk. I've kept my default pool scope limited, as you'll see. since most devices on that subnet are going to have a static IP. But I just find it helpful to have it whenever I'm connecting to the bridge to just grab an IP without messing with static assignment. So let's jump into the interface. So you can see in each one of these pools, I've kind of varied the scope. It's up to you to depend on what your scope is going to be for your DHCP range. So now this will be used for our pool or our scope moving forward. So let's jump into the DHCP server for each one of the VLANs. This is going to allow us to automatically assign IP addresses in each one of the subnets. So let's jump into that interface. So this is where we're going to utilize the pools that we just created in our DHCP server. I'm setting my lease time high. You can set it to whatever you want it to be in your example. And we'll just quickly edit our previous line for our VoIP. Okay, great. In the next example, I'm going to be assigning the bridge to Ether 2. This is going to be my outbound connection to my downstream switch in my environment, and we'll cover that in a future tutorial. But for the purposes of this demo, the switch is going to handle the access ports. Just think of it as such. So let's jump into the interface bridge port. And this may disconnect momentarily as I'm plugged into Ether 2 right now on the actual device, and if that's your case as well, don't worry, you can be able to jump right back in. So I'm gonna now I'm going to create the IP addresses and assign them to each one of my interfaces, my LAN bridge and my other two VLANs, so that they have a reachable address. So jump into the IP address interface. Put it in the correct network. And then my other two VLANs. You know, and this can be whatever you want for your environment as far as reachable IP space. Now you might get disconnected here again as we've modified the IP space, but that's fine. You can reconnect. And we're just going to continue where we left off, assigning the client VLAN a reachable IP space and its network. And we'll do the same for VoIP. Okay, great. Almost done. We're going to go ahead and create the DHCP server's network configuration for each subnet, what it gets handed out. In this example, you'll notice that I'll be using a very recognizable public DNS, but you'll likely just be using your own DNS provider, so just modify that to fit your needs in your environment. So jump into the DHCP server network subinterface. And we'll add the address space for each one of our VLAN interfaces here. This should look familiar. Set the gateway to what it was set in the prior example. Okay, great. At this point, you should be able to pull up an IP address. So we'll just go ahead. So yeah, after renewing our IP address on Ethernet adapter 2 is what I have plugged into my my Mikrotik 450G. You You'll notice that I'm able to pull up a IP address coming off of our trunk port. I'm plugged into Ether2 at this point. Um, you know, see as you see fit, you're able to go ahead and add those remaining scalable ports. I like to leave Ether 1 or Ether 5 available for my WAN ISP, but the others could be added to your bridge as well if you wanted more than one trunk port. Um, Thanks for watching, and let me know if you have any questions.